The entire observable universe is a tiny island in a vast, dark ocean. We can map its galaxies and trace its history back billions of years, but our vision simply stops at a cosmic horizon, a final shore. What lies in the blackness beyond the edge of everything we know is the greatest mystery in all of existence. You are about to explore 25 of the most mind-bending theories scientists and philosophers have proposed to answer this ultimate question. By the end of this journey, you will possess a sweeping understanding of the most profound ideas about reality itself. We will venture into realms of infinite parallel worlds, universes born from black holes, and the possibility that everything we see is a cosmic mirage. What do you believe could be waiting in the void beyond the stars? Our cosmic horizon is not a wall but a shoreline. The first and perhaps most profound theory suggests that what we call the universe is just one island in an endless archipelago. This is the theory of the multiverse. It proposes a vast collection of parallel universes, a cosmic quilt where each patch has its own unique set of physical laws and fundamental constants. In some of these realms, gravity might be stronger, making stars burn out in a flash. In others, the forces that hold atoms together might be too weak, preventing matter from ever forming. The reality we experience, with its specific rules that allow for galaxies, planets, and life, could be just one possible configuration in a staggering cosmic lottery. This idea manifests in several compelling forms. The simplest is known as the Level 1 multiverse. It arises from the theory of eternal inflation, which describes our universe as a single bubble that inflated within a much larger, eternally expanding meta-universe. In this endless sea of space, new bubble universes are constantly popping into existence, each one a self-contained cosmos. The reason we cannot see them is not that they do not exist, but that they are forever beyond our cosmic event horizon, receding from us faster than light can travel. They are not in some other dimension. They are right there in the vastness of space, simply too far away for any signal, any glimpse to ever reach us. Then there is the Level 2 multiverse, a concept that emerges from the dizzying mathematics of string theory. This framework suggests the existence of extra, tiny dimensions of space, curled up in a multitude of ways. Each different way these dimensions can fold and vibrate creates what physicists call a different vacuum state, effectively a different set of physical laws. The landscape of these possibilities is not just large, it is practically infinite. This means that the birth of a universe might be a random selection from this landscape, locking in its particular rules for all time. Our universe, with its 4 familiar dimensions and specific constants, would then be just one possibility among an almost endless variety of cosmic realities. What would it be like to step into a universe where time ran backwards, or where light did not exist? The multiverse suggests that every conceivable reality is not just a thought experiment, but is actually out there somewhere. This concept of a Level 2 multiverse leads us directly into one of the most elegant and complex ideas in all of physics, the cosmic landscape of string theory. Think of the fundamental fabric of reality not as a simple, flat sheet, but as a terrain of unimaginable scale and complexity, with towering mountains and deep, fertile valleys. In this analogy, our entire universe exists within just one of those valleys. The specific shape of this valley, its contours and its elevation, dictates the physical laws we experience. The strength of gravity, the mass of an electron, the very number of dimensions we perceive, all are determined by the local geography of this cosmic landscape. But what defines the shape of this terrain? The answer lies in the way the extra dimensions of string theory are folded. String theory suggests that reality is not made of point-like particles, but of unimaginably tiny, vibrating strings. For the math to work, these strings must vibrate in 10 or 11 dimensions, not just the 3 of space and 1 of time that we know. The reason we do not see these extra dimensions is that they are compactified, curled up into a space so infinitesimally small that they are completely hidden from our view. The key is that there is not just one way for these dimensions to curl up. They can fold and twist in a nearly countless number of stable configurations, perhaps as many as 10 to the power of 500 different ways. Each distinct configuration of folded dimensions creates a different valley in the cosmic landscape, a unique vacuum state with its own unchangeable set of physical laws and constants. Our universe, with its 4 familiar dimensions and its specific, life-permitting constants, simply occupies one of these rare, stable valleys where the conditions are just right for complexity to arise. What lies beyond our cosmic horizon, then, is not an empty void, but an endless, rugged expanse of other valleys. Some of these other universes might be stillborn, with laws so different that matter instantly collapses or flies apart. Others might be realms of pure light, or domains where time behaves in ways we cannot fathom. We are living in one habitable patch in a cosmic quilt of infinite variety, a single possibility actualized in a sea of untold others. That cosmic landscape is not a static sculpture, but a dynamic, bubbling cauldron of creation. This brings us to the bubble universe theory, a breathtaking vision of an eternally inflating meta-universe. Picture a vast, infinite pot of water that is constantly and furiously boiling. Our entire cosmos, with all its hundreds of billions of galaxies, is just a single bubble that formed in that boiling water, a local region where the frantic expansion suddenly slowed down and settled into the more gentle, structured universe we know today. This is the process of eternal inflation. The space outside our bubble is not empty. It is a hyper-expanding medium, a primordial state of space itself that is stretching at an incomprehensible speed, far faster than the speed of light. Within this seething, inflating background, quantum fluctuations are constantly sparking new bubbles, just like new pockets of vapor forming in boiling water. Each of these bubbles is a separate universe, undergoing its own Big Bang event the moment it nucleates. The edge of our observable universe, the cosmic horizon we see when we look out at the most distant galaxies, is not the end of reality. It is simply the inner wall of our local bubble, the boundary where our stable, cooled-down cosmos meets the chaotic, hyper-expanding medium outside. We cannot see past this boundary because no light, no information, can cross it from the outside. The inflating space beyond is stretching so rapidly that any signal from another bubble would be carried away from us faster than it could ever travel. So what lies beyond our horizon is not a barren darkness, but an infinite froth of other cosmic bubbles. Each one is a self-contained reality, isolated from all the others, born with its own random set of physical laws. Some bubbles might instantly collapse. Others might expand for a brief moment before fading away. A rare few, like our own, find the perfect balance to become vast, long-lasting universes capable of forging stars and planets. We are not just living in one universe among many, we are living inside one bubble in an endless, ever-growing cosmic foam. But what if our entire bubble, with all its galaxies and vast empty spaces, is not what it seems at all? This leads us to a theory so radical it challenges our most basic perception of reality itself. The holographic principle suggests that our universe, with its rich three-dimensional tapestry of stars, planets, and people, might be a grand illusion. It proposes that all the information needed to describe every event within our cosmos is actually encoded on a distant, two-dimensional surface that surrounds us. Our perception of a third dimension of depth would then be a magnificent projection, much like a three-dimensional hologram emerges from the flat, etched surface of a piece of glass. In this breathtaking view, the universe is not a volume of space. It is a movie being played back from a cosmic screen. The implications are staggering. If this is true, then the question of what lies beyond our universe takes on a completely different meaning. There is no beyond in the way we think of it. There is no more space out there. Instead, what exists past our cosmic horizon is the source of the projection, the lower dimensional surface where the fundamental data of our reality is stored. It is the master hard drive, the cosmic DVD from which our entire existence is decoded and rendered in real time. This is not just a philosophical idea. It has a firm foundation in the physics of black holes. Scientists studying these objects realize that all the information about what falls into a black hole seems to be perfectly preserved on its two-dimensional event horizon, the point of no return. The holographic principle simply applies this same logic to the entire cosmos, treating the boundary of our observable universe as the ultimate event horizon. So the grand emptiness of space, the dance of galaxies, and the very fact that you are listening to this could all be the result of an unimaginably complex calculation happening on the skin of the universe. We are not living inside a vast container, we are living inside a projection, a cosmic mirage of unimaginable fidelity. Yet if our universe is a holographic projection, what is powering the cosmic projector? A different theory proposes that the cosmos is not a one-time event, but an engine that runs on an endless cycle of death and rebirth. This is the cyclic model, often called the Big Bounce. It suggests that the universe undergoes an infinite sequence of expansion and contraction. What we call the Big Bang was not the beginning of everything, but merely the latest rebound from a previous cosmic collapse. In this view, time has no true start and no final end. It is a loop, an eternal rhythm of creation. The cycle begins with a universe like our own, expanding for billions of years, filled with galaxies rushing apart. But eventually, the collective gravity of all the matter and dark energy in the cosmos reaches a tipping point. The expansion halts, reverses, and the great contraction begins. Every galaxy, every star, every atom is pulled back together in a cataclysmic convergence known as the Big Crunch. All of existence is squeezed into an immeasurably hot, dense state, a primordial seed of unimaginable energy. This is the moment between universes. There is no space as we know it, for space itself is crumpled. There is no time, for the relentless forward march of seconds has been compressed into a single, timeless instant. It is a state of pure potential, a cosmic reset button being held down. Then, from that singularity, the energy rebounds. A new Big Bang erupts, spraying a fresh universe into being, starting the cycle all over again. So what lies beyond our current, expanding universe? According to this model, the answer is not a void or a multiverse, but simply the next phase of the cycle. The great beyond is the future contraction of everything we see, followed by the glorious rebirth of a new cosmos. Each new universe might be subtly different from the last, its physical constants slightly altered by the chaotic conditions of the bounce. This means the stars you see at night, and the planet you stand on, may have existed in countless forms through endless cycles. a cosmic phoenix perpetually rising from its own ashes. That cosmic projector and its endless cycles of rebirth are built on the physical laws we observe. But what if those laws are not just the operating system of reality, but reality itself? This brings us to a theory of breathtaking simplicity and scope, the mathematical universe hypothesis. It proposes a truly radical idea. Our universe is not merely described by mathematics. It is a mathematical structure. In this view, the cosmos is not a physical thing that happens to obey mathematical rules. It is a set of abstract equations and relationships that has taken on a tangible form. You, the stars, and the space between them are all part of a specific, self-consistent mathematical object. If this is true, then the ultimate nature of everything is numbers, shapes, and logic. The implications for what lies beyond our universe are staggering. The mathematical universe hypothesis suggests that every self-consistent mathematical structure has a physical existence. What we call our universe is just one particular structure, the one that corresponds to the equations governing quantum mechanics and general relativity. But beyond our cosmic horizon, or more accurately, outside our specific mathematical set, exists every other possible mathematical universe. There could be a universe built on the simple geometry of a five-dimensional cube. Another might exist where the number pi has a different value, altering the very fabric of circles and waves. There could be realities where time is two-dimensional, creating a plane of pasts and futures instead of a single line. Or structures so alien that concepts like force, matter, or even existence, as we know it, have no meaning whatsoever. The only requirement for a reality to exist is that its underlying mathematics does not contain any logical contradictions. Our universe feels so real and substantial because we are embedded within its particular mathematical framework. We are patterns within the computation. The reason we discover mathematical laws at the heart of physics is not because we are clever, but because we are literally uncovering the code of the system we inhabit. So when we peer into the darkness beyond our galaxy clusters, we are not looking at empty space. We are looking at the boundary of our own mathematical structure. What lies beyond is not more space, but an infinite library of other equations, each one a full-blown universe unto itself. The cosmos is not a place. It is a permanent, unchanging truth in a vast landscape of abstract possibilities. That infinite library of mathematical truths offers one vision of reality. But what if our universe is not an abstract equation, but something far more tangible and nested? A theory known as black hole cosmology proposes that our entire cosmos exists inside a black hole. We are not just looking at black holes in our sky, we might be living within one. According to this idea, the Big Bang was not a true beginning, but the moment a singularity formed inside a black hole belonging to a much larger parent universe. The incredible density and energy of that singularity became the seed for our own cosmic expansion. This completely inverts our perspective. The space beyond our observable universe is not an empty void or a multiverse landscape, but simply the interior volume of our host black hole. The event horizon of that black hole, the point of no return for the parent universe, is our cosmic horizon, the ultimate edge of everything we can ever see. We are on the inside of that boundary, forever trapped within the black hole's cosmic womb. This leads to a staggering fractal vision of reality. Every black hole that forms in our universe could, in turn, be the Big Bang of a brand new universe within it. A star collapsing in our night sky might not be a death, but a birth, sparking an entirely new cosmos with its own laws of physics, stars, and perhaps even life. Our entire universe, with its hundreds of billions of galaxies, could be just one link in an infinite chain of cosmic reproduction. What lies beyond our universe is therefore the universe that gave us life, a parent cosmos whose physical laws might be completely different from our own. And from its perspective, our entire existence is hidden behind the impenetrable veil of a black hole's event horizon. We are a secret, self-contained reality, forever branching off from a greater whole. This theory suggests that black holes are not the ultimate endpoints of destruction, but are instead the nurseries for new worlds, making the cosmos a living, breathing fractal of creation. That cosmic fractal of black holes presents one kind of nested reality, but a different idea suggests that the nesting goes far deeper than space and time. Our universe might not be a physical place at all, but an elaborate digital construct. This is the simulation hypothesis, the theory that everything we experience is part of a sophisticated computational model, a reality so perfectly rendered we cannot tell it from the real thing. If this is true, then the cosmos is not a vast emptiness but a stream of code, and every galaxy and atom is simply a data point in a cosmic processor. The implications for what lies beyond our universe are as profound as they are unsettling. The great beyond would not be more space, but the base reality of the simulators, the higher dimensional realm where the hardware running our simulation physically exists. Our entire history, from the Big Bang to this very moment, could be unfolding on a supercomputer of unimaginable power in that parent reality. What we perceive as the fundamental laws of physics are not laws at all, but simply the rules of the simulation, the programmed parameters that govern how the virtual world behaves. The speed of light might be a processing limit. Quantum weirdness, where particles seem to be in multiple places at once, could be a sign of the program optimizing its resources, only calculating the precise details of a particle when someone is looking. This leads to an even more dizzying possibility, the concept of nested simulations. If a civilization in the base reality can create a simulation as complex as our universe, what is to stop the advanced beings within our simulation from eventually creating their own fully realized virtual worlds? Reality could be a set of Russian dolls, with simulations within simulations, and our own place in that stack might be impossible to determine. We could be the original, or we could be 50 levels deep. So when we peer to the edge of the observable universe, we are not looking at a boundary of space, but at the limit of the rendered distance. The cosmic horizon is the edge of the map, the point where the simulation stops generating detail because no player or no sensor has ever needed to look there. The question of what lies beyond our universe transforms into a question of who or what is running the server, and for what purpose. Are we a scientific experiment, a form of entertainment, or a forgotten archive running on some celestial machine in a reality we can never see? Our reality might be a three-dimensional island adrift in a higher dimensional sea. This is the core of the ekpyrotic and brainworld scenarios, ideas that completely reimagine the Big Bang itself. In this view, our universe is a brain, a shorthand for membrane. It is not a bubble in an inflating foam, but a vast, flat, three-dimensional surface, like an impossibly thin sheet of paper. But this sheet of paper exists within a much larger, higher dimensional realm known as the bulk. We are confined to our brain, unable to perceive or move through the bulk, much like characters living on a single page of a book, completely unaware of the other pages above and below them. According to this theory, The Big Bang was not a singular explosion from a point of infinite density. It was a collision. Our brain, floating peacefully in the bulk, was struck by another parallel brain. That cosmic crash infused our empty brain with an unimaginable amount of energy, heating it in an instant and flooding it with the raw material that would later coalesce into every galaxy, star, and planet. The entire history of our cosmos, from that first brilliant flash to the complex structures we see today, is just the aftermath of that one monumental impact. So what lies beyond the edge of our observable universe? The answer is not more empty space within our brain, but the boundless expanse of the bulk itself. We are surrounded by other brain worlds, other three-dimensional universes, all floating in this higher dimensional ocean. Some of these parallel brains might be almost identical to our own, separated from us by a tiny distance in an unseen dimension. Others could be wildly different, with alien physical laws and forms of matter we cannot comprehend. These worlds are not necessarily forever separate. The same forces that caused the first collision could bring them together again. The brains might oscillate in the bulk, periodically drawing near, colliding, and then moving apart, setting off a new cycle of cosmic rebirth each time they touch. This suggests a universe without a true beginning or end, but one driven by an eternal, rhythmic dance of colossal structures in a hidden, higher dimensional space. The darkness beyond our farthest galaxies is not an end, but a window into a greater cosmic architecture, where our entire reality is just one floor in a skyscraper of unseen dimensions. Another universe is waiting for us, but not in a distant region of space. It exists in the far future at the very end of time. This is the heart of Roger Penrose's conformal cyclic cosmology, a theory that redefines eternity itself. It proposes that our universe is just one chapter in an endless book, a single eon in an infinite sequence. Each eon begins with a hot, dense Big Bang and expands for trillions upon trillions of years until it achieves a state of ultimate emptiness. In this final era, all black holes have evaporated, all matter has decayed into radiation, and even the protons that form the building blocks of atoms have dissolved. The universe becomes a cold, dark, and nearly featureless sea of light particles and gravitational waves. There are no stars, no planets, and no structures of any kind. It is a silent, empty cosmos, stretched so thin that it has lost all sense of scale. And here lies the beautiful, paradoxical key to the next cycle. In this state of maximum expansion and minimal information, the universe loses its ability to measure distance and time. A universe that is infinite in size and almost perfectly smooth becomes mathematically identical to a universe that is infinitely small and incredibly hot. The end of one eon becomes, through a profound geometric transformation, the Big Bang of the next. There is no violent crunch, no singular moment of destruction. Instead, the infinite smoothness of the far future seamlessly transforms into the hot, dense singularity of a new beginning. The universe forgets its scale and is reborn. So what lies beyond our cosmic horizon? According to this view, the answer is not a place, but a time. The great beyond is the future death of our own universe, a death that is not an end, but a cosmic reset. The echoes of the previous aeon might even be detectable. Penrose suggests that the colossal energy released by the evaporation of supermassive black holes in the previous cycle could have left faint, circular imprints in the cosmic microwave background, like ghostly fingerprints from a universe that existed before our own. We are not just looking out into space when we gaze at the edge of the observable universe. We are looking forward to the end of time, and witnessing the prelude to a new dawn. There is a universe where you stopped watching this video a moment ago, another where you are already on your next one. This is the startling promise of the many worlds interpretation of quantum mechanics, a theory that transforms the entire cosmos into a tree of infinite, branching realities. It begins not with galaxies, but with particles. In the quantum realm, particles exist in a blur of possibilities, a state known as a superposition, where they are not in one place or state, but in all possible states at once. The traditional view is that this cloud of potential collapses into a single, definite outcome only when it is observed. The many worlds interpretation offers a far more radical solution. It proposes that the collapse never happens. Instead, every possible outcome of a quantum event does occur, but each one plays out in a newly formed, parallel universe. The moment a particle has a choice, reality splits. Think of reality not as a single, linear path, but as a constantly forking road. Every time an electron spins in two directions at once, the universe divides. One universe gets the electron spinning clockwise, the other gets it spinning counterclockwise. This process is not limited to the microscopic world. Every quantum event that underpins our reality, from the decay of an atom to the firing of a neuron in your brain, triggers these splits. What you perceive as a single timeline with a single set of past events and future choices is just one thread in an unimaginably vast tapestry of what-ifs. So what lies beyond the edge of our observable universe? According to this view, the answer is not just more empty space or other bubble universes. It is every other version of our own cosmos, every road not taken. There are branches of reality where the dinosaurs never went extinct, and mammals remain small creatures in the undergrowth. There are worlds where you took a different job, married a different person, or never even existed. In some branches, the fundamental constants of physics might be slightly altered, creating realities that are almost identical to ours, but where stars burn a little brighter or the force of gravity is a fraction weaker. These parallel worlds are not far away in some other dimension. They are right here, superimposed upon our own, but forever separated from us by the act of quantum branching. We are forever sailing down one channel of an infinitely diverging river, while an infinity of other versions of ourselves sail down their own, completely unaware of each other. The cosmos is not just vast, it is a living story where every possible narrative is being written at once. That endless branching of quantum worlds suggests a cosmos of infinite possibility. But what if our universe has a single, specific point of origin, a cosmic umbilical cord leading back to a parent reality? This brings us to the theory of the white hole and universe ejection. We have already explored the idea that our universe might exist inside a black hole. A white hole is the theoretical opposite of that. A black hole is a region of space where gravity is so intense that nothing, not even light, can escape. It is a one-way street into oblivion. A white hole, by contrast, would be a region from which nothing can enter, but from which matter and energy constantly pour out. It is a one-way street leading out of a cosmic room, a point of pure, relentless emission. If our universe was born from a singularity within a black hole belonging to a larger cosmos, then the initial Big Bang event could be seen as the moment that singularity connected to a white hole in our own spacetime. Our entire cosmos, in this view, is the material being eternally ejected from this one-way gateway. So what lies beyond the edge of our observable universe? The answer could be the interior of this white hole itself. We are not looking out at an empty void, but back toward the cosmic throat that gave us birth. This is not a tunnel we could ever travel back through, as the laws of physics at its boundary would forbid any entry. It is an exit only, a permanent geyser of space-time and energy that defines the very center of our expanding reality. From the perspective of that parent universe, our entire existence is contained within the fleeting flash of a white hole eruption, a cosmic event that might last only a moment from their external timeframe, while containing the entire 14 billion year history of our universe within its own reference frame. We are living inside a burst of cosmic fireworks that is still unfolding, a reality born from a single, irreversible act of expulsion from a greater whole. Our certainty that we are living in a continuous reality, surrounded by a real and ancient universe, could be the greatest illusion of all. This is the terrifying paradox of the Boltzmann brain. It begins with a simple, unsettling question rooted in the laws of thermodynamics. The most probable state of any system is one of maximum disorder, what we call chaos or entropy. A fully assembled, self-aware brain, complete with a lifetime of memories and sensory input, is a state of incredibly low entropy, a highly ordered and therefore statistically unlikely arrangement of atoms. Yet, in a universe that is truly infinite in either space or time, even the most wildly improbable events are not just possible, they are inevitable. Given enough time and enough space, random quantum fluctuations could, by sheer chance, cause all the necessary particles to spontaneously assemble into a fully formed, conscious brain, floating in the void. This brain would flicker into existence with the false memory of an entire past life, believing it has a body, that it is looking up at a night sky, and that it is listening to these words right now. It would possess a complete, consistent reality, a phantom history, only to dissolve back into chaos a moment later. The paradox is this: if an eternal or infinite cosmos makes such random, self-aware entities vastly more probable than the gradual, ordered evolution of an entire universe with galaxies and stars and planets, then you, having this coherent experience right now, are statistically far more likely to be one of those momentary, disembodied fluctuations than a real person in a real, ancient cosmos. What lies beyond our universe, then, might not be other worlds or a multiverse, but an endless, featureless void where the only things that ever spontaneously form are isolated minds, each one trapped in its own perfect, convincing, and utterly false simulation of a universe. The stars you see at night, and the very fact that you can see them at all, might not be proof of a grand cosmos, but merely the fleeting, fabricated memory of a brain that has just now popped into being, alone in the infinite dark. That chilling paradox of a universe populated by phantom minds offers one bleak vision of infinity. But what if the cosmos is not a fleeting illusion, but a permanent, unchanging fixture? This was the promise of the steady-state theory, a once dominant idea that dared to challenge the notion of a cosmic beginning. It is built on the perfect cosmological principle, a grand assertion that the universe is not only uniform in space, but also unchanging in time. On the largest scales, the cosmos would look the same to any observer, anywhere, at any moment in eternity. There is no Big Bang, no initial creation, and no final heat death. The universe simply is, and always has been, and always will be. To account for the observed expansion of space, where galaxies are moving apart, the theory proposed a radical mechanism. Instead of all matter being created in one primordial fireball, new matter is continuously and spontaneously created in the voids between galaxies. As space stretches, these tiny particles of hydrogen slowly pop into existence out of nothing, maintaining a constant average density throughout an infinite timeline. In this eternal cosmos, there is no edge and no center. Every location is the center of its own observable universe, and the grand tapestry of galaxies extends forever in all directions. So what lies beyond our expanding region of space? The answer, in the purest steady-state model, is simply more of the same. More galaxies, more stars, and more of the same physical laws, continuing without end or variation. There is no beyond in the sense of a boundary or a different realm, because the universe is an infinite, homogeneous, and ageless entity. While evidence like the cosmic microwave background radiation ultimately favored the Big Bang model, the spirit of the steady-state theory lingers in modern cosmology. Its core idea, that of a universe without a true beginning or end, finds echoes in the cyclic and multiverse models we have already explored. It forces us to ask whether our entire cosmic history, from a hot, dense state to a cold, dark end, might just be a local chapter in a much grander, eternal story. The darkness between galaxies would not be an emptiness, but a womb for new creation, ensuring the cosmos remains forever alive. Our own universe has a striking mathematical secret hidden in its numbers. If you were to calculate the total mass and energy contained within our observable cosmos, and then determine its Schwarzschild radius, you would arrive at a figure that is eerily similar to the actual estimated radius of the universe itself. The Schwarzschild radius is the theoretical boundary around a black hole, the event horizon from which nothing can escape. This is not a perfect match, but the numbers are so close that it seems far more than a simple coincidence. This leads to a profound possibility that we are not just looking at black holes, but living within one. The event horizon of this cosmic black hole would not be a sphere surrounding a dark object in our space. It would be our cosmic horizon, the ultimate edge of everything we can ever see. From our perspective inside, this horizon is not a wall we are approaching. It is a boundary that is forever receding as the universe expands. We are on the inside of the point of no return. So when we peer into the deepest voids with our telescopes, we are not looking out into an empty infinity. We are staring at the inner surface of our cosmic prison walls, the boundary that separates our reality from the parent universe that gave us birth. The darkness beyond is not a void, but the unimaginable density of the event horizon itself, a perfect reflector that forever seals us off from whatever lies outside. We are eternal residents in the belly of the beast, living in a universe that is, from an external viewpoint, the ultimate dark secret. Yet after contemplating all these cosmic architectures and infinite possibilities, we must face the most unsettling theory of all. What if there is nothing there? This is the hypothesis of the nulliverse, the idea that beyond the edge of our expanding cosmos lies not other worlds, not higher dimensions, but pure, absolute nothingness. This is not the empty blackness of a dark room or the vacuum of deep space. Those are things, places with volume and dimension where particles can pop in and out of existence. The nothingness proposed here is the complete and total absence of everything. No space to expand into, no time to mark a before or after, no quantum fields, no energy, no potential for any form of existence whatsoever. Our universe is not an island in a sea of other islands. It is the only island in an infinite, featureless ocean of non-being. The concept is almost impossible to grasp because our minds are built to process existence. We can picture an empty box, but that box exists within space. We can imagine silence, but that silence exists within time. True nothingness has no properties, no framework, and no reference points. It is not a void. It is the absence of the very concept of a void. Scientifically, this idea presents a profound puzzle. If there is literally nothing outside the universe, then what does it mean for the universe to expand? Expansion implies that space itself is stretching, creating more of itself. But if there is no space outside, what is it stretching into? The question might be a flaw in our language and perception. The universe may not be expanding into anything at all. It is simply that the distances between galaxies are getting larger, and the total amount of space within the cosmic bubble is increasing. There is no external reference point, no outside. The universe is all there is, and it is becoming more of itself. The ultimate horizon is not a boundary to something else. It is the final frontier of reality itself. Why is this so difficult to accept? Because our intuition screams that everything must be contained within something. A fish might not be able to conceive of a world outside its water, but it still knows the water is there. We are trying to conceive of a state where there is no water, no fish, and no container, not even the idea of a container. The nulliverse is the ultimate solitude, a single, self-contained reality floating in a meta-reality of absolute non-existence. It suggests that all of creation is a finite, and perhaps temporary, glitch in an eternal and infinite state of nothing. But if the universe is a computation, then every galaxy and atom is a data point in a cosmic processor. This theory suggests that the cosmos is not a physical place in the traditional sense, but a dynamic information system, a simulation of unimaginable complexity running on a substrate of reality we cannot access. The laws of physics we have painstakingly decoded would not be fundamental truths, but the programmed rules of the simulation, the source code of our reality. Gravity, the speed of light, and the charge of an electron are not discovered by us. They are the initial parameters set by the programmer. This leads to a fascinating explanation for the edge of our observable universe. What we perceive as a cosmic horizon might not be a physical boundary at all. It could be the render limit of the simulation. In a vast, open-world video game, the most detailed landscapes exist only in the immediate vicinity of the player character. The distant mountains and far-off oceans are low-resolution textures, mere placeholders. The game engine does not generate the full, intricate detail of those areas until the player moves closer, conserving processing power and memory. Our universe might operate on the same principle. The reason we cannot see beyond a certain point is that the cosmic computer has not rendered what is there. The galaxies and voids that lie beyond our 14 billion light-year horizon are simply not currently being processed. They exist as potential in the code, but they have not been calculated into existence because no observer, no quantum measurement, has ever required their full rendering. So what truly lies beyond that horizon? One possibility is the raw, unprocessed data of the simulation, a blank space waiting for a command to load. Another, even more profound idea is that we are looking at the source code itself. The boundary of our universe could be the user interface of the programmer, the point where the rules of our reality are written and can be altered. The darkness is not empty, it is the cosmic desktop, the background upon which the reality we experience is actively being drawn. This means the ultimate nature of everything, from the birth of stars to the firing of your own neurons, is a form of mathematics in motion, a calculation happening in real time. The universe is not just governed by numbers, it is numbers, executing in the memory of a computer whose nature we can only guess at. This holographic boundary is not a simple shell, it is the universe's ultimate hard drive. Every event, every particle interaction, and every thought is encoded there as a kind of cosmic pixel. The nature of what exists on the other side of this two-dimensional screen is one of the deepest mysteries. One possibility is that the other side faces a higher dimensional realm, the bulk space we discussed with brain worlds. In this view, our holographic universe is a projection from that greater cosmic volume, like a movie being cast from a powerful laser in a projection booth we can never enter. The boundary would be the lens, the focal point where the complex data of the bulk is translated into the three-dimensional reality we experience. Another, more profound possibility is that there is no other side at all, at least not in a spatial sense. The boundary might not be a surface that separates an inside from an outside, but the fundamental bedrock of reality. What we perceive as the other side could be a void, not of empty space, but of pure potential, a realm where information exists in its raw, unformed state before it is decoded into the physics of our world. This leads to the most staggering idea of all, that the other side of the boundary is the source code of the universe itself. Think of the world around you not as a physical place, but as a magnificent user interface. The trees, the stars, your own body, these are all the output, the stunning graphics of a cosmic program. The holographic boundary is the point of contact with the underlying processor, the line where the executable code is translated into the sensory experience we call reality. The other side is not a place you could travel to. It is a domain of pure mathematics and logic, the foundational instructions that dictate everything from the strength of gravity to the nature of consciousness. The darkness we see at the edge of the cosmos might be our closest glimpse of this cosmic programming language, a visual representation of the ultimate compiler from which all of existence is rendered, moment by moment. The engine powering this infinite cosmic foam is a phenomenon known as false vacuum decay. Imagine the fundamental energy field of the meta-universe as a vast, tranquil landscape, but one that is precariously balanced. This state is called a false vacuum, a condition of high energy that is stable for now, but not truly stable in the grandest sense. It is like a marble resting at the very top of a tall, gently sloped hill. The marble seems stable, but the lowest energy state, the true vacuum, lies at the bottom of the valley. All it takes is a tiny nudge, a random quantum fluctuation, for that marble to start rolling downhill. In the cosmic landscape, when such a fluctuation occurs in a local patch of space, that patch drops into a lower energy state, a true vacuum. The energy released by this sudden transition is cataclysmic, and it fuels a violent, localized expansion of space, inflating that patch into an entire new bubble universe. Our own cosmos, with its Big Bang, was likely born from just such a quantum tremor in the false vacuum. Each of these bubbles forms with its own random set of physical laws, determined by the exact way it settled into its new energy state. Some bubbles might have laws that instantly cause them to collapse. Others might inflate for a brief moment before fading into darkness. And a rare few, like our own, find that perfect golden balance, allowing for a long, complex evolution of stars, planets, and life. This process is not a one-time event. It is eternal. The surrounding false vacuum continues its hyper-expansion, stretching faster than the bubbles can grow, ensuring they never collide or merge. Meanwhile, within the inflating background, new quantum fluctuations are constantly triggering the birth of new bubbles. This creates a self-reproducing, fractal structure of reality that has no beginning and no end. Our entire observable universe, with its hundreds of billions of galaxies, is therefore just one bubble in an infinite, ever-growing froth. We are not merely an insignificant speck in a vast cosmos. We are an insignificant speck in an infinite chain of cosmos generating cosmos, a single leaf on a tree that has no trunk and no end to its branches. The great beyond is not a silent emptiness, but a ceaseless, bubbling cauldron of creation, where universes are born as casually as bubbles in a boiling pot. Dark energy is the silent, mysterious force that seems to be writing the final chapter of our universe, pushing galaxies apart at an ever-increasing rate. Yet, within the cyclic model, this force of cosmic separation might also hold the secret to cosmic reunion. The key lies in the nature of dark energy itself. What if its repulsive power is not permanent, but temporary? Some variations of the cyclic theory propose that dark energy will slowly transform over trillions of years. Its influence could weaken, or it could even flip, becoming an attractive force. Instead of pushing galaxies apart forever, it could begin to pull everything back together, initiating the great reversal known as the Big Crunch. In this view, dark energy is not the end of the story, but the mechanism that sets the stage for the next one. It acts as a cosmic pendulum, first swinging out to create maximum expansion and emptiness, then swinging back to gather all of existence for a rebirth. So what is the universe like in its fully contracted state, the moment before the bounce? It is a state beyond our comprehension. All the matter and energy that was ever spread across trillions of light years is compressed into an inconceivably hot, dense seed. There is no space as we know it, for distance and volume have been erased. There is no time, for the sequence of events has been crushed into a single, timeless instant. It is a singularity, a point of pure potential where the laws of physics as we understand them break down completely. This is not an empty void, but a cosmic womb containing the entire blueprint for a new universe. The chaotic, quantum fluctuations at this moment of maximum compression could be what reshuffles the fundamental constants, ensuring that each new cycle is not an exact copy of the last. The strength of gravity, the mass of a quark, the very number of dimensions might be slightly different in the next iteration. The universe you see today, with its specific rules that allow for your existence, could be the product of a random roll of the dice in a previous cosmic collapse. Dark energy, therefore, becomes the heartbeat of an immortal cosmos, the force that drives both its long, drawn-out exhalation and its sudden, violent inhalation, in a cycle without beginning and without end. This cosmic library of mathematical realities has one strict librarian, the unbreakable rule of logical consistency. The mathematical universe hypothesis presents a cosmos where every valid equation is a real world. But what about the equations that do not work? The ones that lead to paradoxes, contradictions, and impossible statements. The hypothesis makes a profound distinction. These inconsistent structures are not just improbable, they are utterly non-existent. They are the books that can never be written, the stories that cannot be told without breaking their own internal logic. This means the multiverse of mathematics is not an infinite, chaotic free-for-all. It is a vast but curated collection of every conceivable reality that can play by its own consistent set of rules. Think of it as a cosmic constitution. Every universe has a foundational document, its core mathematical axioms. If that document contains a law that says 1 + 1 = 3, but also has laws that inevitably prove 1 + 1 = 2, the entire reality is stillborn. It cannot manifest because it is fundamentally at war with itself. There is no space, no time, and no substance to a reality that declares itself both true and false in the same breath. So what kind of universes are excluded from this grand library? Consider a universe built on the statement, "This sentence is a lie." If the sentence is true, then it is lying, which means it is false. But if it is false, then it is telling the truth about being a lie, which means it is true. This classic logical loop, known as the liar paradox, has no stable outcome. A cosmos founded on such a principle could never achieve a definite state. It would be a flickering, impossible realm, forever trapped between being and not being. Other excluded realities might include universes where time travel is permitted in a way that creates unresolvable grandfather paradoxes, or geometric spaces where a triangle simultaneously has and does not have three sides. These are not just strange worlds, they are impossible worlds because their very definitions are self-contradictory. The beyond our universe, then, is not an indiscriminate infinity. It is a specific, though unimaginably large, set of all and only the logically possible worlds. We do not live in the only possible universe, but we do live in one that is genuinely possible. A stable, self-consistent structure in a multiverse that has no room for nonsense. The darkness beyond our horizon is the boundary of our own local mathematical consistency, and what lies past it is not chaos, but an endless archive of other, equally valid, and perfectly logical truths. If our universe is a simulation, then every galaxy and conscious thought is the product of a programmed reality. This forces a question that transcends physics and enters the realm of the ultimate mystery. Who is the programmer? The nature of the intelligence that could author a cosmos is perhaps the most profound puzzle of all. One compelling possibility is that the creators are our own descendants. A future human civilization, having mastered technology beyond our wildest dreams, might run such simulations as a historical archive, a scientific experiment to study cosmic evolution, or even as a form of profound entertainment. In this scenario, the world beyond our universe is a future version of our own reality, where beings who once looked up at the stars now hold the power to create them. They would not be gods in a traditional sense, but post-human entities whose motives we might one day come to understand. A far more alien possibility is that we are the creation of an intelligence that is entirely foreign. The programmer might be a species that evolved in a universe with completely different physical laws, a form of life so advanced and so different from our own that its thoughts and motivations are utterly incomprehensible to us. Their reality, the world outside our simulation, would operate under what we could only call meta-laws, a set of principles that govern not just one universe, but the very act of creating universes. For such a being, coding a cosmos like ours might be as trivial as we consider writing a simple computer program. The simulation could be one of countless others running on a celestial computer of unimaginable scale, a mere background process in a reality of a higher order. The most metaphysical possibility is that the programmer is not a biological or even a physical entity at all, but a fundamental, conscious principle underlying all of existence. It could be a form of cosmic mind that uses simulation as its method of expression or self-exploration. In this view, our universe is not a deception, but a thought in the mind of a god-like consciousness, and the laws of physics are the logical constraints of its imagination. The world beyond our horizon would then be the mindscape of this entity, a realm of pure thought and information where the concepts of space and time do not apply. So when we look into the deepest voids of space, we might not be looking at an empty expanse, but at the edge of the user interface, the boundary of our rendering engine. The darkness is the screen, and the programmer is the silent architect watching from the other side, for reasons we may never be designed to comprehend. These ghostly imprints from other dimensions might already be hiding in our data. The question of what lies beyond our universe is slowly transforming from pure philosophy into a testable scientific inquiry, and the key might be gravity. Gravity is curiously weak compared to the other fundamental forces. A tiny magnet can lift a paperclip, effortlessly overcoming the gravitational pull of the entire Earth. Why is it so feeble? The brainworld theory offers an elegant explanation. It suggests that the particles of gravity, known as gravitons, are not confined to our brain like everything else. They can leak. They can drift off into the higher dimensional bulk, effectively diluting their strength within our three-dimensional realm. This leakage would be a faint but detectable signature of the larger cosmos surrounding us. If we could observe gravitons escaping our brain, it would be direct evidence that our universe is not all there is. We are actively searching for this. Elaborate experiments are trying to measure gravity at incredibly small scales, looking for deviations from the predictions of general relativity that would hint at gravity's ability to seep into these extra dimensions. Another potential piece of evidence is written in the oldest light in the universe, the cosmic microwave background. This faint glow is the cooled remnant of the Big Bang, and it holds a perfect snapshot of the infant cosmos. According to the brainworld scenario, our Big Bang was a collision with another brain. Such a colossal impact would have sent powerful gravitational shockwaves rippling through the fabric of our newborn reality. Those shockwaves would have left distinct, circular patterns in the cosmic microwave background, like the concentric rings from a stone dropped in a pond. Astronomers are meticulously scanning this ancient radiation, searching for these telltale imprints of a long-ago encounter with a parallel world. Finding them would be like discovering a fossilized fingerprint from the cosmos that gave us birth. These are not just abstract ideas. They are active research programs that could one day provide our first empirical glimpse into the bulk, the vast, hidden ocean in which our universe is just one floating sheet. The darkness beyond our horizon may not be empty, but filled with the faint, detectable whispers of our cosmic neighbors. This probabilistic nightmare points toward a deep crack in the foundation of cosmology itself. If an infinite multiverse makes every possible fluctuation inevitable, then the number of conscious brains that randomly flicker into existence for a single, diluted moment should vastly outnumber the conscious beings who arise from a long, ordered, biological evolution. The universe should be overflowing with these phantom minds, each one convinced it is living in a real world, while genuine cosmic histories like our own are statistically drowned in an ocean of momentary illusions. So why does our reality feel so continuous and structured? Why are we not a Boltzmann brain? This is the core of the measure problem, a philosophical crisis about how to count possibilities in an infinite reality. In an endless cosmos, the concept of probability breaks down. How do you decide what is likely when everything happens an infinite number of times? The answer must be that the true architecture of what lies beyond our horizon is not a formless, eternal chaos. It must have a structure that somehow favors the emergence of stable, ordered universes over transient, random fluctuations. Perhaps the initial conditions for cosmic inflation are finely tuned to produce low-entropy beginnings, making vast, coherent realities like ours the standard output of the multiverse, not the exception. Or maybe the laws of physics in the meta-universe inherently discourage the spontaneous formation of complex information, rendering Boltzmann brains far less probable than we fear. The fact that we exist within a 14-billion-year-old cosmic story, complete with a documented history from the Big Bang to galaxies, suggests that the great beyond is not a random generator of nonsense. It is a cosmic factory calibrated for producing enduring narratives, not fleeting solipsistic dreams. Our very existence is a powerful clue that the multiverse, in all its immensity, is built to tell long and coherent stories, not just to whisper forgotten lies in the dark. Perhaps the ultimate answer to what lies beyond our universe is not a place, but a principle. We have journeyed through a gallery of cosmic possibilities, from holographic projections to cosmic bounces. But there is one final, unifying theory that ties them all together. It is the dream of a final theory of physics, a single, elegant set of equations that perfectly describes all the forces of nature. For decades, scientists have searched for this theory of everything, hoping it would reveal the one, true, unique universe we inhabit. Yet, a startling possibility has emerged. The ultimate theory might not describe a single cosmos at all. Instead, its most beautiful and self-consistent form may inherently predict a vast, and perhaps infinite, ensemble of universes. The equations themselves might be fertile, giving birth to a multiverse not as an afterthought, but as an unavoidable mathematical consequence. In this view, our universe is not the solo performance of reality, but one instrument in a grand cosmic orchestra, all playing from the same fundamental sheet of music. What we perceive as the bizarre, finely tuned constants of nature, the strength of gravity or the mass of an electron, might not be unique. They could simply be the local bylaws of our particular cosmic neighborhood, while the fundamental laws are the universal constitution governing the entire meta-reality. The quest for a final theory then transforms. We are not searching for the story of our universe alone, but for the genesis story of all possible universes. The profound mystery of what lies beyond our horizon becomes a direct output of the most basic rules of existence. The darkness is not emptiness, but a canvas upon which the fundamental laws paint in infinite variation. So the final answer to our great question might be this: that the beyond is not a separate realm, but the natural, breathing expression of reality's deepest and most beautiful truth. From the endless branching of quantum worlds to the silent, absolute void of the nulliverse, we have charted a spectrum of cosmic possibilities as vast as the mystery itself. We have wandered through infinite bubble universes, contemplated our reality as a holographic projection, and faced the unsettling notion that everything we know could be a sophisticated simulation. We have peered into the cyclical rebirth of a cosmic phoenix and considered the profound simplicity that our universe is all there is, a single island of existence in an eternal sea of non-being. Each theory is a testament to the audacity of the human mind, a radical attempt to answer the ultimate question. The true answer may forever lie beyond our grasp, shielded by the very laws of physics that govern our reality. Yet the value of this grand pursuit is not in a final answer, but in the journey itself. Every time a scientist devises a new experiment to detect gravitational leakage, or a philosopher untangles a new logical paradox, we are pushing the very boundaries of what it means to know something. We are expanding the frontiers of science, philosophy, and human imagination, reaching with all our collective might into the darkness. So now, we turn this final question over to you. After this journey to the edge of understanding, which of these 25 theories resonates most deeply in your mind? Does the infinite multiverse feel like home? Or does the elegant simplicity of a cyclic cosmos speak to you? Share your most compelling or mind-bending idea in the comments below. Let us continue this conversation, this great collective wondering, as we all gaze up at the same mysterious sky. And if you are ready for more journeys to the limits of knowledge, Be sure to subscribe for our next exploration into the unknown.